take a lot of time from us. And being a competitive exam, that is not a good idea to do that. So we have to find some theorems, some tricks, and then apply, then get an answer from that. So we'll see how to do that. Okay. So first question is that we are given a Lorentz series of this analytic function. And the Lorentz series is of this form, as you all know, right? Now, where is this Lorentz series existing? Of course, it exists in this annulus, right? What is this annulus? Inside of this thing, where this is mod z equal to 2 and this is mod z equal to 1. So what is the question? You are given a Lorentz series expansion. You need to find what is the A3. A3 means the coefficient of Z cube. I'm sure that you can all find the answer. Please try it once, then I will do. It should be found within 5 or 6 seconds. Once you finish, please let me know. So I think you are putting in the chat. So it's not visible for me as I am presenting. So you can directly open your mic and let me know.
Okay, dear participants, please feel free to share your answer. You can.
Let it be wrong, let it be right. Never mind.
Please unmute yourself and.
Sir, D answer, sir.
Yeah, of course. D is the answer. Thank you for responding. So we'll look into the solution. So as you all know, this is an B part question. I think from June 2017 or something. So what is the F that is given? F is 1 by Z minus 1 times Z minus 2. So we know that we cannot factorize, we cannot find the Lorentz series when this is a product like this. So the better and the easiest way is to factorize them. How to factorize? This will be some combination of this, right? So instead of putting this as some A by this thing, then doing the entire calculation, it is better to write like this. Then find what is this. Okay, I'm going to give a plus. Then what is this? Z minus 1 plus Z minus 2. So it is not going to work, right? Here we need a minus. So what is this? This is 1 and denominator is the product. So we can understand that this is the factorization. So what I'm telling is that you cannot always find such calculations very easily. But at this point of time, we can do that, right? So better way is to find the factorization like this, not like A divided by something plus B divided by something and finding out A, B while substituting. So that is not a good thing to do in net exam. So now we know that the Lorentz series expansion of this thing is easy. How can we modify this thing? We can take minus 2 outside. And what is this? 1 minus Z by 2. And this is plus 1 by 1 minus Z. But you have to think a little bit. Where does the Lorentz series exist? The Lorentz series does not exist on mod Z less than 1, right? It exists on mod Z less than 2 and mod Z greater than 1. So to find a series expansion for this thing, what we have to do? We have to get something of modulus less than 1. 1 minus something of modulus less than 1. So what is the better option? You can take z outside, then it is 1 minus 1 by z. Now see, 1 by z has modulus less than 1. So this has a Lorentz series expansion. What is the Lorentz series expansion? This is minus 1 by 2 times summation n equal to 0 to infinity z by 2 power n and minus 1 by z times n equal to 0 to infinity 1 by z power n. Now what is the question? We are asked to find A3, right? A3 means the coefficient of z cube. So what is the coefficient of z cube in this part? When n equal to 3, that is minus 1 by 2 into 1 by 8. Now, what is the coefficient of z3? Remember, there is a z here. So, we need to find the coefficient of 2. In any case, it is 1. So, this is minus 1. Am I right? Hello? Am I right?
Yes, ma'am.
Okay. Then what is the answer for this thing? It is not coming, right?
Why minus 1, ma'am?
So, what is the coefficient of? Okay, so that is the issue. What is the coefficient of z power 3? It is not asking about coefficient of 1 by z power 3. That is the issue we faced. So the coefficient of z cube here is 0. That is why the answer is 1 by 16. Okay. Have everyone understood? This is such an easy problem. But remember, calculations will make mistake. So always be careful with your calculations while you are doing your net exam. Shall we move on to the next question? See, you have to respond, right?
Yes, ma'am.
Yeah.
Yes, ma'am.
Okay, if at least one of you are saying that it is not true or I didn't understand, then I can repeat. Otherwise, you can quickly say this is easy, move on to the next. So, look here. This is also an easy problem. So, what is given? A is a real number. Everything we have to be specific when we are in the exam hall. It is given, it is real. Means we have to use that A is real. Okay, somewhere we have to use A is real. If we are not able to use A is real and we are finding some other answer, then you have to think always that we are wrong. So A is in real number. Now what is given? The integral of a function on this circle is pi. What actually is that circle? A circle centered at I and radius 1. So this is the circle, mod is at minus I equal to 1. Now what is the question? When we are integrating this function, what is that function? F is it equal to 1 by z square minus z plus a on this circle, then it is going to give me pi. Now we need to find the value of a. I'm sure that you can. So let me wait for a minute. You can try. After that, I will explain. Why I am doing this is that If I am going on doing the problems, only I will learn. So if you want to learn actually for the exam, then you have to work out. So better you work out, then I will do. And also be quick. Time management is a very important problem in complex analysis. Once you finish, please let me know. If there is someone who cannot even start with this problem, please let me know. I will give you a hint to start. Don't waste your time simply sitting that I will do and all. Please don't put any chat to me. I can't see.
Give some hint, ma'am.
Okay, that's it. So one thing which we have to note is that F is having a singularity. Why? If F were analytic on the circle and inside this circle, then by Cauchy's integral formula or Cauchy's theorem, what will be the answer? The integral will be 0. But given integral is non-zero constant, right? So what should we understand? This Fz is going to have, or this 1 by Fz is going to have a 0 inside this contour or that circle. Till this you understood? The one who asked me to give a hint.
Yes.
Okay. So the first thing we have to strike is this. Now next thing is that, okay, so I need to find a 0 of this thing, right? What is the best option to find a 0 of this thing? What actually is the denominator? Come on, what is the denominator?
A quadratic function.
Yeah, of course, it's a quadratic function. So we know to find the zeros of a quadratic polynomial, right? What is the 0? Z will be minus b plus or minus root b square minus 4, the coefficient of z square and the constant term 4ac by 2. Okay. So the roots depend on A. Now comes the role of A is in R. So the next thing what you have to do is that have a look into this roots. What is this? It is 1 by 2 plus something. So 1 by 2 is somewhere here. Actually, the circle does not passes through this thing. It just touches, right? So 1 by 2 is somewhere here. Now, what is this thing? 1 by 2 plus or minus something. So if this set is entirely in the real part, then what happens? It doesn't have a 0 inside that circle. Got it?
Yes.
Yeah. But we need a 0 inside that circle. Is there any question?
Can you repeat one more,
Okay.
ma'am?
Yeah, sure. So what we were looking into the denominator such that the denominator have a 0 inside the circle, right? So what I am telling is that the zeros are precisely these things. 1 plus square root of 1 minus 4a by 2 and 1 minus square root of 1 minus 4a by 2. Right? So the next thing we have to think is that if these sets, the plus or minus things, are entirely in the real line, then the zeros are not inside the circle, then of course the integral have to be 0, but it is not 0, right? So one thing which we got is that the roots are not purely real, they are complex. Understood?
Yes, ma'am.
Okay. Now, how can they be complex? The only way to have the roots to be complex is that 1 minus 4a will be less than 0. Right? So we can take it to be I times root 4a minus 1. Now see, these are the roots of these things. Then again we have to do one more thing. Which root is inside that circle? That is the question we were searching for. Then the figure will help you. See, this is 1 by 2. 1 by 2 plus I by 2 means it is going to the I by 2 direction. Somewhere here. But 1 by 2 minus I by 2 means it is going to the negative direction. It is not in the circle. You got this geometry?
Yes, ma'am.
Okay. So the root inside that circle is precisely this thing. 1 by 2 plus I by 2 square root of 4a minus 1. Now we modify our FZ slightly. See, FZ is GZ by Z minus Z naught, where GZ is analytic inside and on C. C is the circle. Now what is this GZ actually? Of course, this is Z minus Z naught into FZ, right? Now what is this thing? The roots were Z naught, and let me call Z1 equal to 1 by 2 minus I by 2 square root of 4a minus 1. So GZ is actually 1 by Z minus Z1. Agree? Agreed?
Yes, ma'am.
Okay.
Yes,
Now
ma'am.
what is
Yes, ma'am.
given? Okay. Now what is given? The integral over Fz, which I am modifying like this: 1 by Z minus Z1 by Z minus Z0 times dz is actually pi. Now we can apply the Cauchy's integral formula. What was the Cauchy's integral formula telling us? If we have, yeah, it is. This is actually 2 pi I g of Z0.
So,
Okay. So what is g of Z0 we have to find? What is g of Z0? 1 by Z0 is 1 by 2 plus I by 2 square root of 4a minus 1 minus Z1 is this thing. So minus 1 by 2 plus I by 2 square root of 4a minus 1. This is precisely 1 by I square root of 4a minus 1. So what actually is this thing? Okay, I can cancel pi and pi. This is 2I into 1 by I square root of 4a minus 1. I and I get cancelled. And that side is 1. So what we have is that 2 is same as square root of 4a minus 1. Or otherwise, 4 is 4a minus 1. and A is 5 by 4. See the option 5 by 4. Have everyone understood?
Yes, ma'am. Yes, ma'am.
Okay, so the thing that you have to remember in such kind of questions is that, first of all, while reading complex analysis question, see whether some conditions related to R, C, or some domain, say unit disk or something is given or not. Then identify the known formula and the question. So here, as soon as we see this equation, we will strike, our head will directly go to Cauchy's integral formula. Then think how can we apply. Then we will come to the answer automatically. Okay, so this is how you have to attack a question. Even though we
Ma'am,
are, okay, tell me.
ma'am, here 1 minus 4 is less than 0. Why you attack?
Okay, so that is the question. That's a very nice question, which I already explained, but I will explain once more. So, what was the zeros of z square minus z plus a? These things, right? 1 plus or minus square root of 1 minus 4a by 2. What was we actually searching for? A zero of this polynomial inside that circle. Now, if this set is entirely on R, means 1 plus something, right? So 1 plus something, set not is here. And 1 minus something, set not is, set 1 is here. If the roots set not and set 1 were like this, then there are no roots inside the C. Means what? The integral by Cauchy's theorem is 0. But it is given a non-zero constant pi. So what we came to know is that this is not purely real number. This much you understood?
Okay, ma'am. Thank you.
Okay, so next you understood how it was negative?
Yes, ma'am.
Okay, then fine. Anyone have any more doubts? Okay. Then we will move on to the next question. Okay, so this is a purely theoretic kind of question. What is the question asking? F is an entire function. C to C analytic means entire function. Then, in the which of the following cases f is a constant? Means whether A condition implies f is a constant, whether B condition implies f is a constant, whether C implies f is a constant or D implies f is a constant. So A, B, C, D are the statements that they have given. The option is here. So think about this thing. Recall all
Only
the
C will
theorems.
be done. So only C. That means range of F will be C minus I.
You are talking about the answer.
Yes, ma'am.
No, that is not the answer. Don't worry. Since you have openly interacted with me, I will let you know how it comes. But let others also think for a minute. The
Ma'am,
question,
A, B, D.
yeah, of course.
In
So,
those cases, F will be a constant.
yeah. So, seems you have understood all the theorems of complex analysis. So, that is the kind of way we have to approach the theorems and we have to approach the net exam. Be thorough with all the theorems, not just mugging up. Just try to understand what the theorems are telling and how we can apply in the results. So let everyone think. We'll wait for a minute, then we will start. So this is a easy question. So we'll wait for 10 to 15 seconds and then we'll start. Okay. Hope everyone could have figured one, that is A. What is A telling you? What actually is A telling you? Can someone tell?
Boundedness of F.
Yeah. Yes.
And range is contained in a ball.
Yes, range is contained in a ball, and that ball is bounded by 2023.
2023.
Yeah, so means what? F is bounded.
F is bounded.
Yeah, it is already given, it is analytic. What theorem suddenly comes to your mind? Yeah, Liouville's theorem. So Liouville's theorem says what? Then F is a constant. So the one who said only C, have you understood?
Yes, ma'am. Actually, I thought that F can be
False.
only these three. Actually, I
Okay,
did
okay.
not see the question fully.
Yeah, okay. So be
If F
careful.
can
This
be
is
only
one of
then
the reason which we can lose marks.
yes,
One
ma'am.
thing is that they might have been asked for which of the following is false. We
Yes,
might
ma'am.
have
Actually,
answered
I
for both
used
of them.
Picard theorem that F can be only C.
Okay, okay.
If it's not constancy function, then
Yes,
thank you.
yes. Okay.
Mm.
So what is B telling us? Range is a upper half plane. Means what? Range is this thing. But what
Some
is
range
Picard
of F
theorem?
leaves many points.
Yeah, range of F leaves many points. Picard's theorem says that
Like
range of F can leave only at most 1 point.
most one point.
Yeah, so from the Picard's theorem itself, we can neglect A, B, and D. C, range of F is leaving at least 2 points, right? So B and D, everything leads to F is a constant. Now, what is an example for C? That is, range of F is actually C minus I. F is analytic, still F is not constant. What is an example?
1/z minus I.
1 upon Z minus iota.
1 by Z minus I is analytic.
Z plus I, ma'am.
Z plus I is analytic and it is having the entire range. So if the question would have this thing, answer will come in 1 or 2 seconds. Give me an entire function whose range is C minus
1
H.
minus I, ma'am.
What? E to the power?
1 minus
1 minus?
I.
This is a constant, right? E to the power 1 minus I.
Sorry. E to the power Z minus I then.
Okay, I understood that you are coming to the answer, but think e to the power Z minus I means it is going to leave 0.
E raised to
But it
power
is
z.
not going. Yeah, e power Z means it is going to leave 0. So we need a function which is going to leave I. Means what?
I minus. What is problem with 1 upon Z minus iota?
You're talking about 1 by Z minus I.
Yes, ma'am. It is not
What is the
analytic at
definition at I?
iota and analytic everywhere.
What is the definition of f(z) at I? That's my question. What is f of I?
And it is tending to infinity.
Hmm?
Sorry.
Sorry, I didn't hear you.
Oh.
You understood what is the issue? Hope you might understand. Okay. So e power z is not going to attain 0 anywhere, right? Means e power z plus I is not going to be equal to I. So this is the function which is satisfying this analytic and non-constant. Why I talked about this is that You have to find out some counter examples very quickly in some of the example options. So if you just tick, okay, A, B, D, I know it is not C, and then go on to the answer. At the time of exam, it is okay. But while calculating or while practicing, you have to know each and every option. Shall I move on to next?
Yes, ma'am.
Okay. Okay, so this is a tricky question, but very simple. So what is given? Fz is sine pi z by 2 by sine pi z. Then f has a pole at. Think a little bit, then answer.
B and D.
Okay. So shall I explain or anyone needs time to think?
It will be pole when the sine pi z is actually 0, right? Or
No.
oh,
We need only to consider whenever sine pi z is 0. But it doesn't say that whenever pi z is 0, then it is a pole. Because sine pi z by 2 may also give you 0 and it may lead to a removable singularity. Understood?
yes, ma'am.
So what are you telling is that if I have a function like this, so you are telling that we need only to check whether 0 is a pole of this or not. In this case, what is actually this thing? It is a removable singularity. Is it so? No, right? You understood the difference between pole and removable singularity?
Yes, ma'am.
Yeah, it is a pole. At 0, it is having a pole. But see this thing. Does it have a pole at 0?
No.
No, it has a
No,
removable
ma'am.
singularity at 0. So the thing is that if at all we have to check for some poles, it must come from this part. Means what? Pi z is n pi z. N pi means z is n. N is an integer. Now find all those n's for which this thing is also 0. When will this come to 0? N is even. Right? So whenever n is even, this thing is going to be a removable singularity. So whenever n is odd, this is going to be one something which is non-zero, and the denominator is going to be 0. At that point, we know that it is going to be a pole. So all odd integers will give me a pole. Of course, 4k plus 1 is an odd integer. So it will also give me a pole. But all integers, will all integers give pole? No, we have seen for n equal to 2, this is not giving a pole. For all even integers, of course no. So have you understood how to figure out?
Yes, ma'am.
Okay. Okay, now this is also an easy question. a set is given. A set A is given to be the zeros of this equation. Okay. Now find the cardinality of A. That is whether it is 0 means this equation is never going to be 0, or whether it is having finitely many roots, whether it is having countably many roots, whether it is having uncountably many roots. This is the question. Think about 30 seconds, then answer.
C, man, C.
See, yes.
See, let's not.
Yeah,
See.
Aleph. Yes. So how you all did to solve this thing? We will multiply by e power z. E power 2z is minus 1. So minus 1 means what? Here, right? What is that? 1 times e power I pi. Now only pi? No. N pi. 2n pi. Pi
2n plus 1
plus
into
1
pi.
pi. Yeah. 2n plus 1 pi. So this is 1 pi, 2 pi, 3 pi, 4 pi. You can check like that. So this is 2n plus 1 into pi. Means what? Set takes these values. And n is countable. Hence, the zeros is also countable. Such an easy question, right? But this have occurred in net exam. So, this is an interesting question, but easy. See,
Ma'am,
it will be
what is
one.
Z in the previous question?
What?
What is Z in the previous question?
See,
Yeah.
this is called as Aleph knot. My handwriting may be bad. So, the Aleph knot means the cardinality of natural numbers. Okay?
Cardinality of?
Natural numbers.
Okay, ma'am.
Or cardinality of a countable set.
Okay.
Okay.
Thank you.
Yeah, thanks for
Ma'am, in this question, how are we knowing to multiply by e raised to z? How can we get that intuition?
Okay. Then how will you solve an equation this thing? You will be doing, of course, this thing, right?
Yes, ma'am.
Next, what will be doing? What can we do? Nothing can be done, right? So the idea is to get something like e power, not to is that we are hoping for something e power something equal to a complex number.
Okay, ma'am.
Then there is a way to solve because the polar representation exists. Always this is a better idea. So whenever we are asking for find the roots of cos hz, cos hiz, sin hz, etc.
You
You
are
just
using for e power z plus e power minus z is nothing but cos z. It's a very easy way.
yeah. So any kind of such things. This is some causes it. So here is cos iz, 2 cos iz, and we are asking about the zeros. Okay,
Okay, ma'am.
and the zeros, in fact, we are not mugging up. The proof is exactly coming like this. But for net exam, you have to remember such things. Don't do such calculations. Okay. So try this thing. Px is a polynomial of degree at least 2. Then the radius of convergence of this power series, P of n, set power n. Try this.
Ma'am, the video started previous question.
Oh, is it so?
Yes, ma'am.
Is it the same for everyone?
Yes, ma'am.
Yes, ma'am.
Okay, I will close and then share once again.
Now it's okay.
Yeah, okay, okay.
Now
Okay.
it's okay.
Yeah, sure.
It will be B1.
Option B.
Okay, how? What you calculated? Anyone please tell. What have you calculated?
Radius of a polynomial is always 1.
Radius of polynomial is always 1.
Suppose take an example P of n. Then we calculate the limit n tends to infinity an plus 1 by an.
Yeah.
So
So
we
that is
get
the method. Yeah. So what will happen? Say, let this be a naught plus a1 x. So I will write it in terms of n itself. A d n power d, because it's of degree d. So what is this thing? A naught plus a1 into n plus 1 plus etc. plus ad into n plus 1 power d, and in denominator it is a naught plus a1 n plus etc. plus ad n power d. So the biggest coefficient, biggest power is n power d, divided by that a naught by n power d, a1 into n plus 1 by n power d, ad into 1 plus 1 by n, and denominator is again so as n tends to infinity, this numerator is going to be ad, and the denominator is also going to be ad. So the limit is 1. And this is how we calculate the radius of convergence. Got it? See if
Hello.
at least one, yeah, tell me.
So, it's necessary that get them equal to 2. If question is that for any degree, then it is also true.
What? I
Polynomial
didn't.
of degree is given greater than equal to. If it is not given greater than equal to, normally it is a polynomial of any
Yeah,
degree. Then it will also.
it is true.
Okay, ma'am.
Yeah. Because otherwise, of course, you cannot take a means you cannot take a series kind of thing. So they are just restricting to some D, but to make this option some sense, they have given D greater than or equal to Q. Otherwise, it is same. If D is at least 0, then it is a constant. It's converging. And if D is 1, then again it has a radius of convergence. Everything happens. D greater than or equal to 2 is just for making us confused about it depends on D or not.
Okay.
Yeah. So this is another one. 1 by Z. That's 0.
Ma'am, it will be C.
Start. Then let me know.
1
Don't
by
wait.
E.
Yeah. Clues that how can we find such an answer very quickly. You can also
So
share.
I just expand the e to the power x. Yes, ma'am. Then take
Yeah,
common
expansion
of
is
the coefficient of 1 by z only. Because residue we have to find at z equals to 0.
finished. Yeah. Or you need to wait. Okay, then I will explain. So e power something. What is something? This has an minus equal power 1 by z power. One by z.
No, actually it is stuck.
Oh, it is stuck. N equal to 0 to infinity minus thing is e power 1 by z. Now a mistake can occur. Now are you able to
Yes. Ma'am.
hello? Okay. So the mistake that we is the coefficient of 1 by z. So this is k factorial and k. Okay. N, the coefficient of one. From this series, we will compute
Ma'am, now also stuck and the
N equal to
voice
0
is
to
also
infinity.
not clear now.
Oh, what's that? Sir,
Yeah, yes. Yeah, you can continue. There is no problem.
Ma'am, are you writing something on the board?
Yeah, now visual.
visible.
Yes, Sneha, now it is visible.
Okay, fine. Okay. So one mistake that we'll do is that, and this is one. And for each n this happens, so we will find this thing. And this is actually 1 by e. But the thing that we have to set n times means it is n times product. So the here rest all is picking out 1. Second thing is that pick out 1 by set from this part. Rest all is 1. N times 1 by set. So actually from and then so we are going to start with an entire function. Then what is given is that for each point in the complex plane, there exists a natural number which will of course depend on z such that the nth derivative of f at the point z is going to be 0. Now, which of the following is are all false? So take your time, think on this question, then answer. And meanwhile, if my audio or my presentation is not clear, let me know.
Hello.
Yeah.
What is the answer of previous question? 1 by e. Am I right?
Minus 1 by e. Minus 1 by e.
Can you again explain the last part?
Yeah, sure. So
That
what?
time was
Okay, I will explain. What I was telling you is that there might be someone who calculated the coefficient of 1 by z to be 1 for each n. And for those who calculated like this, the answer will be 1 by e. But that is not the case. So what actually is the coefficient of 1 by z from this? That has to be calculated like this. For each natural number n, this is a series. And that series is expanded like this, n times that series. Is this visible?
Yes.
Okay,
Perfect,
now
ma'am.
how can you find the coefficient of 1 by z? The coefficient of 1 by z comes from, if I am taking 1 by z here and multiplying 1, 1, etc. 1, that is going to be first 1 by z. Second 1 by z occurs when I pick 1 from here, 1 by z from here. Okay, I will tick doubly. 1 by z from here and rest is 1. And third 1 by z becomes the 1 by z from the third part, 1 from the rest of things. Similarly, for each n, you will have a 1 by z in the nth part and 1 in the rest parts. So the coefficient is actually going to be n. You noticed it? Also notice that for n equal to 0, there is no coefficient of 1 by z. Right, the entire series is going to be 1. So the coefficient for each n greater than or equal to 1, coefficient of 1 by z in this part is n. Now comes the coefficient of 1 by z in the entire series. So what is the coefficient of 1 by z? This is summation n equal to 0 to infinity minus 1 power n by n factorial. Coefficient of 1 by z for n equal to 0 plus coefficient of 1 by z for n bigger than or equal to 1. Got it? And for a, sorry, this summation is not like this. This summation is for each thing. Okay. Yeah, for bracket it is true. And what is coefficient of this thing? That is 0. So it only starts with n equal to 1. Means this is actually n equal to 1 to infinity minus 1 power n by n factorial, and coefficient of 1 by z is n. That is n equal to 1 to infinity minus 1 n by n minus 1 factorial. This can be slightly modified. How? Take a minus outside. Let n starts from 0. Then it will be minus this thing and n factorial. And this is what is minus 1 by e. So the answer is minus 1 by e, not 1 by e. Be careful with this thing. That is what I was telling you. Clear?
Yes, ma'am. Yes.
Okay. Now the next question. So here f is given to be analytic, means entire. And for each point you pick from C, there is an element in natural number such that nth derivative of f at the point z is going to be 0. Now, which of the following is false? Is or are false? This is the question. Think about it. It is a very important question. If you can solve this thing, then you are done with complex analysis.
Ma'am, BCD.
What? Yeah, BCD, yes.
Yes, ma'am.
Okay. Once everyone is okay, I will start. What? You were telling BCD?
Yes, ma'am. BCD false.
Yeah, BCD is false. So, have you proved that it is a polynomial? Or just looking into the options you told that BCD is false?
Ma'am, it will be a
No, actually
polynomial
it will
of
be a
n minus 1
polynomial.
degree.
Yeah, it will be a polynomial. Can you prove that I'm asking?
Yes, ma'am.
Okay. So, I will start, okay? What is given? It is not given that fn of z is 0 for all z, and which implies f is a polynomial. This is not the explanation. This is false. Can anyone tell how you proved that f is a polynomial? This proof is really nice. That's why I'm asking.
Actually, ma'am, the coefficient a n will be 0 for some n. So it will
Yeah, for
leave
some
actually
n,
n.
will be 0.
Yes, ma'am. So n minus 1 degree polynomial we can get for each z in C.
What? No, it is not like that. That's why I said this is not the case. What actually is f? F is actually
Ma'am,
summation.
Taylor series. Yes, ma'am.
Yeah, Taylor series expansion.
Yes,
A
ma'am.
n
Taylor
z
series
power n.
expansion. And for some n is equal to 0.
Yeah.
Sorry.
For each z means for each z, you are getting different n's. I will be writing nz such that f nz is going to be 0. Means if I take z is equal to 1, I will be getting n equal to 3. That is third derivative of f at 1 is 0. But if I take z equal to 2, I will be getting some other n. It is 5. So this thing is 0. But this doesn't mean that fifth derivative at 1 is 0 or third derivative at 2 is 0. It doesn't mean that fn at every z is 0. That's why I'm asking you how you got it as a polynomial. Understood my point?
Analytic function can be written as a polynomial, power series expansion.
But power series is not a polynomial. Polynomial have only finitely many coefficients. The other things must be 0.
Finite, then other elements are 0, so it is a polynomial. By power series, can get it can be written as a to the power 1.
So is it my issue or is her voice breaking?
Yeah, that is, I think, her issue.
Okay,
Voices.
sir. Okay, then I will explain this thing. This is not as you said. The thing is that consider the set in this part. Whichever uncountable set you can take from C. Okay. So this is an uncountable subset of C. View it as an uncountable subset of C. Now, give this map. Let me call this map to be A. So for each set in that 0, 1, assign it to that n set which is making this thing to be 0. Till this you understood?
Yes.
Yeah. Now look into the thing. A is from an uncountable set to a countable set. Right? Means what? There will always exist an n naught in n. N naught doesn't mean n0. There, okay, I will write n prime in n such that A inverse of n dash is at least countable. This you understood? Okay, what if not? If not means what? For every natural number n, the inverse image is going to be a finite set. But finite union of countable union of finite sets is countable. So it is not going to cover the entire 0, 1. So this means there is at least one natural number n dash whose inverse image is going to be at least countable. This you understood?
Yes.
Okay. Take that particular n naught. For simplicity, I am taking that n naught to be m. And we know that A inverse of n dash is countable. So let me take some sets. So this is this set. This is the set implies A Z n is actually M for all n. Okay. Now this is a bounded set in C. Why? The entire domain itself is bounded. So this is a bounded set in C. Means this will have a convergence subsequence. Bolzano's theorem. So let me call that convergence subsequence to be Zn case. Okay. Now what is the property of Zn case? A Zn case is going to be M. And which means the mth derivative of f acting upon Zn case is going to be 0. So you have a limiting sequence and an analytic function with 0 on that countable set. Which theorem do you remember? An analytic function with a limiting sequence. Some theorem do you know about this thing? Hello? No one knows that theorem? Cauchy integral theorem? No. You know identity theorem? So if G is analytic,
Yes, ma'am. And contain its limit point
yeah,
of the set of zeros, then it will be identically zero.
yes. So G is analytic containing limit point of its set of 0. Then G is identically 0. So what is actually G here? F power m. Mth derivative of f is also an analytic function. And that analytic function is going to have limit of zeros because we are always taking sedans from a compact set. Its limit is also in that set. Means what? Fm is identically 0. Now comes your argument. Fm is always 0 means Fm plus 1 to derivative, Fm plus 2 to derivative, everything is 0. So F is going to terminate in M. Understood? This is how F is a polynomial and this is how F is necessarily 0 is wrong. F is necessarily constant is wrong because we can just take the identity function. For each set, you can take M to be 2. F may not be a polynomial. That is also wrong. F is in fact a polynomial. Got the answer?
Yes.
Okay. Next one. This is quite easy, but I have a remark on this thing. You try this thing. P is a positive integer. Consider the closed curve e power it 0t, which is the unit circle. Hello?
Ma'am,
Yes.
ma'am, before the problem, I have a doubt, ma'am.
Yes.
For that, f is not necessarily a constant, it's a false statement. But f
Yeah.
may be a constant is right only, ma'am.
F may be a constant. That is right.
Yeah, okay.
Yeah.
Thank you.
Okay. So this is the curve R, and they are giving that this F is holomorphic in a big R. Here, our radius is 1. So what they are telling is that if this is of radius R, our F is analytic in this region. Means what? F is analytic inside and on R. Then what are they asking? If F has a 0 only at set naught, and that set naught is in 0 to R. Here is my doubt. Okay. So this is a net question. If set naught is in R. So for the time being, I am assuming that set naught is inside the circle. And it is of multiplicity Q. Then find this thing. Assume that Z is inside the unit circle. Then you can easily find the answer. Once you are done, let me know. You have to use F has a 0 only at Z naught and is of multiplicity Q. That has to be used. So start with that. We have to be a little bit quicker. So if you are done, let me know. Okay, we'll start anyway. What is given about F? F is having only 0 at Z naught. And that too of multiplicity Q. So this is of the form this thing, where G is analytic. G is analytic. And G of Z naught is not equal to 0. Now, what actually is given? F dash by F's integral. Anyway, we know to compute F dash. What will be F dash? Q Z minus Z naught power Q minus 1 G Z plus Z minus Z naught power Q G dash Z. We have to compute this thing. What is this thing? This is Q by Z minus Z naught plus G dash Z by G Z, where G is not having any zeros inside the circle. Got it? Till this you got?
Yes, ma'am.
Okay. Now we have to look into the integral. What is the integral? Integral of this thing plus integral of this thing. This is not going to have any zeros inside the circle. So by Cauchy's theorem, this is identically equal to 0. Now we have only think about this thing. What can be used? Which theorem comes to your mind?
Cauchy integral.
Yes. And what is the Cauchy integral? So 1 minute. There is some set power p remaining. Yeah. So there is set power p here. So set power p. Anyway, with set power p also, this is analytic. So this is 0. And use the Cauchy's integral formula here. What is the answer? Q times set naught power p is there. Now in the question they have 1 by 2 pi I. Okay. And the Cauchy's integral formula is having 2 pi I times f, means the function's value at set naught, and there 1 by there 2 pi I. So the answer is,
Ma'am,
yeah,
why the second integral is 0?
because g dash is analytic, g is analytic, and g is not going to have any zeros inside the circle. Why? The only zeros of f inside the circle is z naught, and z naught is not zero of g. Got it?
Yes, ma'am.
Okay. So the answer is Q z naught power p. So if we are looking at this question, we will be stuck how to start with this f dash by f. We don't know anything about f. But then remember, there will be some condition to start with, and which you have to identify. Okay. See this. This is really easy, you can do. Gamma is a positively oriented circle in C given by this thing. What is actually that circle? Center is 1, radius is 1 by 2. This is gamma. Now calculate this integral. We'll give you 30 seconds. Calculate fast.
Option A.
Yes. So these things I will directly solve because everyone knows, but this do come for the net exam. So what are the zeros of this function? This is set minus 1 into set plus 1. And the zeros in, so the discrepancy that I missed here is that they have given mod z is less than, mod z naught is less than r. But what if this is in this part? Then integrating will give us 0, right? But the answer is nowhere 0. So that is an issue in that question. But whenever you see such an issue in that question, and if you are not getting full part of that B part, if you have to attend 25 questions from B part, and if you know only 24 out of that, surely, for sure, and if you know that this question is wrong, please do attend this question. Depending on the validity of the question, CSIR may cancel the question or give marks for those who attended that question. So at least if you're not sure about the other part, and if you're sure that this question is wrong, then please do attend that question.
Ma'am, where was it wrong? I did not got it.
Okay, so we assumed that the set naught is less than 1, right? Mod set naught is less than 1. Then only we could do this thing. What if the mod set naught is greater than 1 and less than r? Then there is no discrepancy inside this circle, right? Integrating is
Yes,
with
ma'am.
respect to r, so the value is going to be 0 according to Cauchy's theorem. But that is not in the option. Okay. So if someone point out that this question is wrong and it is having this discrepancy, either they will cancel that question or they will give marks. So better is to attend that question. Now, what is the zero? The only zero inside that thing is 1. So this is going to be the singular part. The other thing is having z e power 1 by z by z plus 1. Now act 1 upon this thing. And that is e by 2 and into 2 pi I. So the answer is e pi I. That's all. Okay. So this is the conceptual question, but very easy. But all these questions are from net only. You can see how easily we can score in complex analysis. So f is a holomorphic function on a unit disk. Of course, this is the unit disk. And it is given that mod f is greater than or equal to 1 on D. Means what? Mod f is greater than or equal to 1 for every set in D. And it is also given that f of 0 is I. What can be the values of f of 1 by 2? Think a little bit and then answer.
Option B.
B, I,
Yeah. So what can be
because
means?
it will be constant.
Yes,
Constant
of
function.
course.
It will be.
So,
Maximum modulus principle.
yes.
Maximum modulus.
Yes, very good that you know. What is maximum? Attain its minimum or maximum, whatever it means. Inside that disk, then it's going to be the constant function. So, see, it is going to attain, right? Whether they are same. Find all ends, check whether this is in this thing and all. This you can do by your own. So, take a screenshot or I will share the PDF. Work out by your own. So, now the question is that f is an entire function. Hope you can see and understand, even though my voice is breaking. F is an entire function and f is satisfying this thing. So define a set x to be the zeros of its derivative and y to be the zeros of this equation. Now which of the following are true? Try your own, then let me know. Yeah, now I'm audible.
Yes, Neha. Yes.
Okay, okay. So once you finish, please let me know. And for those who are not starting anything, try to find a function satisfying this thing. That's your basic ODE. Whenever such questions appear in exam and you are getting nothing to start with an example satisfying that thing. At least you can disable the options.
Then B and C.
Think a little
C
bit.
and D.
C is
F is
Then we
equal
have
to
to differentiate.
tell a function that is satisfying all things. Consider f is equal to this thing. Sin square z. What is this thing? Cos square z. It's 1, right? Is it okay? Or still my voice is breaking?
I think it's okay.
Hello.
Yeah, Sneha, I think it is okay now. Hello?
So now.
Hello, Sneha.
Now
Yeah,
it's
it's
okay?
okay now.
yes, ma'am.
Sir, I can't hear you. Anyway,
Hello, Sneha, are you hearing me?
so FSL sign set. Yes, sir.
Yeah, your voice is clear now. Please continue. Hello, Sneha, are you hearing me? Okay.
Yes, sir. Now I can hear. Yes, now I can hear.
So I think we can finish with this problem and go for an interactive session. I think
Yes,
some
I'll
issues
finish.
are with your network maybe.
Sinusoid is satisfying this condition. So what is x? The limit points of the zeros of f dash z means the zeros of cos z, which is to
Sneha, are you writing something? It is not appearing.
either x or y is going to have a limit point that we cannot conclude from this thing. If y is having a limit point, then f dash is z means sin is z. So it is always 0. So y is c. So if y has a limit point, yes, y has a limit point. But f dash is a constant. No, f dash is actually cos z, which is not equal to constant. Means B is wrong. Now, fz is always in 1 and minus 1. Range of sin z is the entire C. So this is also wrong. Now what we have to prove is that A and C is true. Now we have f square plus f dash square is 1. Differentiating we have 2f f dash plus 2f dash f double dash is 0. That is f dash into f plus f double dash is 0. So what is this thing? Either f dash is 0 at something or f plus f double dash is 0 at something. So if x is considered to be the zeros of f dash and y is considered to be the zeros of